This is Falcon Launch Control, T-minus 20 minutes, 20 seconds and counting. We're going to go now to the International Space Station control room at the Johnson Space Center in Houston, where our ISS commentator Brandy Dean is standing by to give us a status of the readiness of Houston to support the flight.
T-minus 20 minutes.
LC, verify all previous auto and procedures.
Thanks, George. Good morning and welcome to Mission Control Houston, where the team here in the International Space Station Flight Control Room has been following along with preparations for tonight's launch and anticipating the planned demonstrations that will hopefully lead to the first docking of a commercial vehicle with the International Space Station on Tuesday. Leading the team here at the Johnson Space Center is Emily Nelson, the Orbit 1 flight director for today. However, assuming all goes as planned this morning, Holly Ridings, the lead NASA flight director for the SpaceX demonstration mission, will be taking over once the Falcon 9 gets off the ground. In preparation for today's launch, the team here in Houston has already given their go for launch after a no-go poll here in the room. That verified that all of the systems that would be used for docking are indeed ready to be called into action, and the ground network connections used to connect Mission Control in Houston with the SpaceX team in Hawthorne, California are in good order. This launch and the upcoming docking of the Dragon capsule to the International Space Station are the product of many years of preparation on both the NASA and SpaceX side, and the two groups are prepared now to function as one team. Awaiting the Dragon and its cargo, some 1,014 pounds of food, clothing, and supplies. In space is the newly expanded Expedition 31 crew. Commander Oleg Kononenko and flight engineers Don Pettit, Andre Kuipers have been anticipating and preparing for the Dragon's arrival for some time now, and they were recently joined early Thursday morning by new crewmates Gennady Padalka, Sergei Revin, and Joe Akaba, who have made it just in time to witness the historic docking firsthand. The International Space Station will be about 249 miles above the North Atlantic Ocean between Labrador and Ireland at the time of the Falcon 9 launch, coming up now in just 18 minutes. Once it has launched, of course, the Dragon capsule will begin its journey to the space station, performing a series of tests as it makes its way there to prove that it will be able to dock safely with the station when the time comes. The Dragon will be demonstrating its absolute GPS system using global positioning system satellites to determine its location, conducting a free drift demonstration to allow the spacecraft to float free with all of its thrusters inhibited, and then perform a demonstration of its abort capability to ensure that it can move away from the station if necessary. This has all been tested on the ground and verified by NASA, but now will be validated on orbit before the systems are used in a safety critical situation near the space station. Assuming that all goes well, Dragon will be ready on Monday for its fly under of the International Space Station. That'll be the first time that the station has the chance to communicate with the Dragon, and the first time that the crew on orbit will send commands to Dragon and get a response. Dragon there will perform a series of burns on Monday to bring it to a point 1.5 miles below the space station and establish communication with the space station to perform a test of its relative GPS using a relative position of the spacecraft to the space station to determine its location. While it's nearby, the crew will also turn on a strobe light aboard the station to verify their ability to send the vehicle commands. That's going to be important on Tuesday when it's time for them to bring the Dragon in for docking. Once these fly-under tests are complete, the Dragon will fire its engines and begin a loop around the International Space Station at a distance of 4 to 6 miles and get set up for its chance to re-rendezvous with the space station on Tuesday. Again, assuming all goes well, on docking day, the Dragon will again be moving into position 1.5 miles below the station. The go is given by the team here in Mission Control. A burn will be performed to bring the vehicle within less than 1 mile of the station, and then there will be another go-no-go decision in Mission Control before it moves into 820 feet for another demonstration, this one of its LiDAR system. The flight control team in Hawthorne will then command the Dragon to approach the station, and it will move into 720 feet, and after another series of tests performed with the help of the crew and several more go-no-go decisions, the Dragon will be finally ready to dock with the International Space Station. Docking will be performed using the space station's 58-foot-long robotic arm by flight engineer Don Pettit with help from flight engineer Andre Kuipers. They'll use the arm to grab onto the Dragon once it's at a point 32 feet away from the station, and then bring it in for a berthing to the Earth-facing port of the station's Harmony node. That's scheduled to take place at 10:20 a.m. Central Time on Tuesday, and the crew has been practicing for this task since before they left Earth in December. From there, it'll be a matter of opening the hatches between the Dragon, and the crew will begin work of unpacking its cargo, a task that's scheduled to take about 25 crew hours in all. So we'll be looking forward to all that here in the International Space Station Flight Control Room following this morning's launch, now just 15 minutes away. This is Mission Control Houston. Back to you, George.
This is Falcon Launch Control, T-minus 15 minutes and counting. We're only about 2 minutes away from hearing the launch team pick up with their final polls and readiness to go into the automatic countdown sequence, which starts at T-minus 10 minutes. We're not working any issues. The weather is favorable. The range is go. So we are still targeting a 4:55 a.m. liftoff of the Falcon 9 rocket this morning. At T-minus 14 minutes, 32 seconds and counting, this is Falcon Launch Control.
T-minus 14 minutes. Stand by for the final poll at T-minus 13 minutes. All stations verify ready for launch. All stations acknowledge. FTS.
FTS ready.
Prop.
Prop ready.
AVI.
Avionics ready.
GNC.
GNC ready.
Ground.
Ground is ready.
VC.
VC's go.
GC.
GC's go.
DC.
DC's go.
RC.
RC go.
OSM. OSM.
OSM go.
ROT.
Range is ready.
CE.
CE is ready.
LD.
LD is go.
MD.
MD's go.
LD, verify go to initiate terminal count.
You are clear to proceed into terminal count.
T-minus 12 minutes.
GNC, prepare for the final print INAV command.
GNC ready.
This is Dragon Launch
T-minus.
Control, T-minus 11 minutes and counting. The International Space Station is flying over Florida right now. In just about 50 seconds, we'll be picking up with the automated countdown sequence for the last 10 minutes of the flight. We're continuing to count down toward a 4:55 a.m. liftoff. We're now at T-minus 10 minutes, 36 seconds and counting. This is Falcon Launch Control.
Auto sequence. BC shall not abort the idle sequence after T minus 10 seconds, and operators shall not call a hold after T minus 15 seconds. If a hold is called, all operators proceed to the terminal account and abort contingency procedure in section 10.59. Attention all personnel, stand by to pick up the count. T minus 10 minutes and counting on my mark. Three, two, one, mark. BC announced the idle sequence has started.
Dragon terminal count and F9 terminal count have both continued.
RCO confirm the clock is counting.
Water deluge setting up.
GCBC stand by on FireX.
Standing by.
RCO confirm the clock is counting.
Clock is counting.
OSM set launch and able to flight.
Switching to flight.
Pre-valves are coming open. Aux bleeds are open. We are now chilling in the engines.
Prop confirms all pre-valves open.
T minus 9 minutes.
Next event, Dragon goes to internal power at T minus 8 minutes.
T minus 8 minutes. T minus 7 minutes.
The next major command will be to direct the flight computer to begin its final alignment. That occurs at T minus 6 minutes 17 seconds.
Vehicles in self-alignment.
T minus 6 minutes.
Stage 2 TVC bleed has started.
The
T-minus 5 minutes.
Vehicle and pediport systems are setting up for
what?
Stage 1 and Stage 2 are going on internal power.
Telemetry
We're
and
on internal power on Stage 1 and Stage 2.
telemetry and video transmitters now being turned on.
Vehicle release auto sequence is starting.
T-minus 4 minutes.
The
Ground TTEB system setting up.
vapors from the cryogenics surrounding the base area of the launch pad.
FTS on internal power.
S2 TVC motion complete.
About to terminate LOX topping.
Pre-valves are coming closed.
T-minus 3 minutes.
LOX load is ending nominally.
FTS, verify FTS is armed.
FTS is armed.
SpaceX Launch Director Brian Mosdell is
First and
about to
second
give his
stage fuel
status.
trim valves are in their flight positions.
LD, verify go for launch.
LD is go for launch.
Next, we'll have a go from the range.
Stage 2 heaters is ending nominally.
Rock, verify range go.
Range green.
T-minus.
Pre-valves are coming open for one last engine chill. Helium load is ended nominally.
And at T-minus 1 minute, the flight computer will be commanded to the startup state.
Engine
Valves
purge
open
ISOs
for
open.
flight. First stage engines are chilled in.
Vehicles in idle.
T-minus 1 minute.
Vehicles in startup. First and second stages are pressing.
First stage TVC motion looks good.
T-minus 30 seconds.
Standing by now for taking the tanks to flight pressure and activating the pad deluge water system.
T-minus 20 seconds.
20 seconds. The main engine controller commands will give the command to start the engine sequence at T-minus 3 seconds. We're at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff. We've had a cutoff. Liftoff did not occur. We've had a launch
Proceeding
abort.
Terminal count launch abort.
We've had a launch abort
BC abort
standing
terminal
by.
count sequence if not already aborted.
We did
Verify
not-
the flight computers are not startup.
We did not get confirmation from the first motion sensor that liftoff occurred.
BC verify
Vehicle
the
is-
flight computer is not in startup.
Flight computer's not in startup.
Flight computer
GCV,
is not in
reactivate
startup.
firex if fire present at the launch mount.
Copy.
OSM, verify you're ready to safely FTS.
OSM, verify ready to safety FTS.
Copy.
Right now the vehicle is being safed. The ignition sequence had started, but there was a cutoff.
BC, verify all computers are in manual mode. Preval, no box bleeds.
Prevals are closed, aux bleeds are open.
BC, verify S2 internal, S1 internal aborted.
That's confirmed.
AVI, verify vehicle power is nominal.
Vehicle power is nominal.
OSM, set launch enable to inhibit.
Switching to inhibit.
BCs, perform the following steps to get TPC back to manual mode. Set S2 TPC mode to manual and open the S2 fuel vent valve.
Setting stage 2 TPC to manual, opening up fuel vent.
Prop, report when ready to vent the S2 LOX tank.
Props ready.
BC, open the S2 LOX tank vent.
Stage 2 octane vent coming open.
BC, set S1 TPC mode to manual and open S1 fuel vent valve.
S1 TPC going to manual. Fuel vent coming open.
Prop, report when ready to vent the S1 LOX tank.
Props ready.
BC, open the S1 LOX tank vent
S1
valve.
octane vent valve coming open.
BC, verify close the S1 flight aux fill and drain and the S2 flight aux fill and drain.
It's verified.
DC, verify Dragon has aborted and is in a stable configuration.
Verified.
GC, verify the fill manifolds are vented, S1 and S2 LOX interface, and S1 and S2 RP interface.
Verified.
GC, verify water and deluge ring press valve secured by terminal count abort auto sequence.
Secured.
GC, verify the TVC tank is vented.
TVC tank is vented.
GC, verify T-tap secured by terminal count abort auto sequence and complete the following.
That's in work.
GS, verify data hourly rollover is enabled.
Confirmed.
AVI, determine the need to initiate battery charge sequences.
We do not need to charge.
BC, ticket not perform in step 59.20, battery charging not required. AVI, instruct VC to cycle power on transmitters to keep the temperatures within launch limits.
Copy.
The
BC.
International Space Station crew has been advised that there was a cutoff in the launch sequence and liftoff did not occur.
23.
Roger. Verify nominal FTS state.
Copy. Safe and arms are in the safe state. Ordnance interrupters are in the safe state. FTS is on external power, and FTS state is nominal. Is that correct, OSM?
Roger.
LD, the vehicle is safe.
LD copies. As reported by flight software, we had an abort on engine 5, chamber pressure high. LC, please continue to proceed through scrub securing.
Copy. That's in work.
Okay, thanks so much, Dave.
Okay, proceeding to section 10.62. OSM, reestablish roadblocks at the BDA.
In work.
GC, disable the vehicle fill and drain interlock controls.
In work. Complete.
And as we heard, the computer saw a parameter that it didn't like. And that's what that is for. Once ignition occurs, it has a last chance to look at everything to be sure all of the engines and the entire launch vehicle is ready for liftoff. And the computer did see a parameter out of spec, so that did cause the engines to shut down. The vehicle is stable. It's in a safe configuration. And we'll begin a recycle activity once the abort checklist is complete.
One of our engine controllers observed a high pressure chamber pressure and shielding fluid.
LCGC within the scrub site safing auto sequence. Are you ready to raise the strongback?
GC is ready.
LC's ready.
Copy that.
W2-hour turnaround for launch attempts.
Entering 1 to proceed with strongback raise.
See no constraints on the flight hardware that would not allow us to support the target.
Excuse me. Copy. Didn't work.
Initially, we're planning a 72-hour scrub turnaround. Launch on Tuesday morning. 22nd would be 3:44 a.m.
Are you ready to turn off RF power?
ABI is ready.
RC's ready.
Copy that. Entering 1 to proceed. Prop direct GC to cycle stage 1 fuel bleed FV64 as required.
Copy, will do.
Copy that. LWO provides scrub turnaround and exposure weather forecast. Strongback is at approximately 88 degrees.
Yeah, strongback being returned to vertical, completely flush, adjacent to the Falcon 9.
GC within the strong back raise auto sequence. It's TE vertical and ready to close the cradle. TE is vertical, ready to close cradle. Copy that. Proceeding. GC within the cradle close auto sequence, entering 1 to loosen upper cradle.
Copy that.
LC this OSM.
Go ahead, OSM.
Yes, sir. Do you want to take a couple of sweeps around that we don't have any fires?
Copy, will do.
Thank you.
VC this LC on the countdown net. Go ahead and move the securing steps to net A.
Copy that.
OSM, this is LC on the countdown net.
This is OSM.
Yeah, we panned around the flame tunnel area. Didn't look like any fires.
Roger, we didn't see any. From all the scanning that you're doing, it looks like it's pretty clean.
This is Falcon 9 Launch Control. We will be having a post-scrub press briefing at 6:30 a.m. Eastern Time this morning. And we will, at that time, be able to provide some insight into the circumstances and also about our next launch attempt, which would be on Tuesday the 22nd. So at this time, this will conclude our coverage until the briefing at 6:30 a.m. Eastern Time this morning. This is Falcon Launch Control.